ಎಲ್ಲ ಮೆಸೇಜ್ ಮಾಡಿ hello everyone, hello, can you hear? Hello everyone, I hope all of you are here. Okay, so I'll write the problem now, then we will solve it. Okay, so I hope you can see this. Write down the question. The escape speed of a projectile. The escape speed of a projectile on the Earth's surface. On the Earth's surface. On the Earth's surface is 11.2 kilometer per second. A body is projected, right fast. A body is projected out with the thrice its speed. Thrice its speed. What is the speed of the body? What is the speed of the body? Speed of the body far away from the earth. Far away from the earth. Ignore the presence of sun and other planets. Ignore the presence of sun and other planets. I hope I am audible to you. This message, hope I am audible to all of you. Okay, ignore the presence of sun and other planets. So see here, we know the expression. This is an escape speed of Earth's surface. So it is projected with the thrice the speed. So its kinetic energy, its initial kinetic energy is half m 3ve square. 3ve square is an initial kinetic energy. That will be, whereas there is some potential energy. So potential energy will be utilized to overcome, the escape speed or whatever the kinetic energy that we give for the projectile initially will be used up to overcome the gravitational potential energy. Gravitational potential energy. Then what is the speed? That is how it is. This is a final velocity at the space. So this is initial kinetic energy utilized to overcome the gravitational pull of the earth. That is why it is called escape speed. The energy, kinetic energy initially, which will be used up to overcome the gravitational potential energy, and whatever the remainder will be remaining as final potential energy. Final kinetic energy, final kinetic energy. So half m everywhere it is common. 3ve square is equal to v square plus vf square it is. So what happens now? It is 3ve square minus v square is equal to vf square. Vf is root 2 VE square. which is VE into root 2. So the answer should be VE is given already. For Earth surface it is 11.2 kilometer per second into root 2. So by calculating this, what should be the answer? Okay, the answer that we are getting is about it is 9v square over here. Squaring this up, it will become 9v square. So this is root 8v square. This is 2 root 2. So this is 2 root 2. So value calculating this, you will get 31.7 kilometer per second is the final velocity. Okay, kilometer per second is the final velocity. I hope all these things are clear. Okay, so I think for B1 students, escape speed derivation is not over. So I will do it quickly. This is just almost the same steps, but a little opposite in terms of its concept. Where you are in gravitational potential energy, where you are trying to pull a object from infinite distance to a given point, correct? From an infinite distance to a given point. Here you try to escape, you try to project an object with the initial speed such that it will escape out of Earth's gravitational pull. So what is escape speed? Write down V1 or Yagi answer. Escape speed is the minimum speed. Okay, so it is the minimum speed with which a projectile is projected so that it escapes Earth's gravitational pull. So that is called escape speed. Okay. So coming back to the derivation. Okay. So for some of the batches it might be second time, but I guess there are about 10 to 12 students in B1. For them this is not over, I suppose. So I'll do it fast. Okay, just try to understand. See, suppose the object is here and you displace it only by a small distance dr. Then small work done in displacing the object of mass m by dr, then dw is equal to f into dr. But see, if the gravitational force is acting this way, the external force acts in the opposite direction. So minimum you have to apply gravitational force to do the work. So total work done will be integration of dw from Only if you go to infinity, the potential energy becomes zero. Then you can at least just get it out of Earth's gravitational influence. Starting from RE, from the surface. RE, suppose if I do this, then what will happen? It is G M by R square dr. Suppose R is the distance between from the center to the object. Illi the object, R is the distance. Up to here the radius is RE. Then what happens? Work done will be okay. So see from here if I write visible. So work done is however the work done is opposite to the gravitational force, so it is minus GME M by R square. So minus GME M integration RE to infinity R to the power minus 2 dr minus GM M, that is R to the power 1 minus 1 RE to infinity. So it is W is minus GME M minus divided by minus 1 it will be there, so it will become plus now due to this minus 1. So GME M 1 by infinity minus 1 by RE it will be. Okay, so work done will be change in kinetic energy, that will be minus GME M by RE. So final kinetic energy minus initial kinetic energy minus GME M by RE it will be. So for the object, just to escape Earth's pull, Earth's pull, final velocity should be zero if it is projected with escape speed, because by the definition of escape speed VE, not minimum speed means as you go to higher altitude, rather as you go into space at an infinite distance, its velocity will be zero, so that it won't come back to Earth's surface. It is just escaping out of Earth's gravitational pull. It is just escaping out of Earth's gravitational pull. So for the object to just escape Earth's pull, minimum speed if you have projected, that is called escape speed. Escape speed is the minimum speed. Minimum speed means it will just escape out of Earth's pull, so that its final energy, kinetic will be zero, final velocity will be zero. Initial speed is obviously VE. Then what happens? Final kinetic energy is zero. Initial kinetic energy is half m VE square is equal to minus GME m by RE. So here minus sign m cancels off. VE is equal to root 2 GME m by RE. Inside the root, this m is cancelled out. This m is not there. So this is an expression for escape velocity. Now if I multiply this here, root 2 GME by RE, multiply this by RE, divide this by RE, VE will be root of 2GRE, root 2GRE. So this is an expression for escape speed. In NCERT book, this is an expression for escape speed. Okay. So this is how derivation must be done. So for those who have done this, this will be just like revision. But for V1, please take it down fast. Okay. Any doubts? You can message. Any doubts? Manoj, are you there? Manoj from Guruvayur, are you there? There are 100 localized students, already only 50 are watching, where rest of the 50 has gone wandering or what. Okay, so this is about escape speed. Then we'll solve one more problem. Okay, solve one more problem. Write down the question. A rocket is fired. A rocket is fired vertically. A rocket is fired vertically with the speed fired vertically with a speed of 5 kilometers per second from the Earth's surface, from the Earth's surface, okay, from the Earth's surface. How far from the Earth? How far from the Earth does the rocket go? Does the rocket go before returning to the Earth? Before returning to the Earth. mass of the earth, mean radius of the earth g. So given mass of the earth 6 into 10 to the power 24 kg, mean radius is equal to 6.4 into 10 to the power 6 meter. I told you these values. Universal gravitational constant 6.7 into 10 to the power minus 11 Newton meter square per kg square. So we have to calculate by this. See, if a rocket is projected with the initial speed, okay, V naught, how much? 5 kilometers per second. It will go up, reaches a maximum height, then it will come back. Correct? So we have to calculate the height h. So from the center, I call this as R. From the center it does go, no? So from the center you have to calculate the distance, obviously. So write down the question fast and try to answer that fast. Try to answer that. So write down, let R be the distance from the center of the earth. Let R be the distance from the center of the earth. From the center of the earth. Let R be the distance from the center of the earth where the rocket reaches. Where the rocket reaches before returning. Correct? So if the maximum height its velocity will be 0, no? So that implies final kinetic energy is 0. Then what about initial kinetic energy? Initial kinetic energy, Ki it will be, initial kinetic energy is half m vi square, or vi square, I write. So this is vi, 5 kilometers per second. You don't know what is the mass of the rocket anyway. Mass of the rocket is potential energy. So initial potential energy Ui is minus Gmem by Re, that is radius of the earth. From the surface it is 500, no? So it is minus Gme, mass of the earth is 6. The value we are going to substitute later. Later we will do this. Okay. Then what about final potential energy? Final potential energy UF will be minus GME m by small r, because it reaches to that height. So by conservation of energy, final kinetic energy plus final potential energy should be initial kinetic energy plus initial potential energy. So ಏನಾಗ್ತದೆ ಈಗ ಅದು ಹೇಳಿ, final kinetic energy is 0, final potential energy minus Gmem by R is equal to initial kinetic energy half m Vi square minus initial potential energy GME M by RE. This is what we are going to get. Okay, now M I can take common throughout, that cancels. Anyway, bring this to this side. This will be GME M 1 by RE minus 1 by R is equal to half M Vi square. So M and M cancel off. So it is now 2 into GME by 1 by RE minus 1 by R is equal to half. I have taken to this side now. So what is Vi? 5 kilometer per second square. Now substituting the values. 2 into 6.67 into 10 to the power minus 11 into 6 into 10 to the power 24 into 1 by 6.4 into 10 to the power 6 minus 1 by R is equal to 25 into 10 to the power 6. So this 10 to the power 6 cancels off and this will become 10 to the power 18. 10 to the power 18 it will become. So here calculating this, 12 into 6.67 into 10 to the power 7, 1 by 6.4 into 10 to the power 6 minus 1 by R should be equal to 25. Okay, should be equal to 25. Right up till here. Fast. Okay, I'll change the pen. So now, see, if I write it here, okay, clear, no? Now, see, what I do is, this I can multiply, 12 into 6.67, so, 12 into 6.67, 80.04 into 10 to the power 7, 1 by 6.4 into 10 to the power minus 6 minus 1 by R is equal to 25. This is fully equal to 1 by 6.4 into 10 to the power minus 4 minus 1 by R is equal to 25 by 8.04 into 10 to the power minus 7. Calculate this fast. 25 by 8.04. The value is 0.3123 into 10 to the power minus 7. And this one This is 10 to the power 6 now here. 10 to the power 6. So this will be 10 to the power minus 6. 1 by 6.4 becomes 0.1563 minus 1 by r. So 1 by r will go to this side. So what happens now? This is 1.563 into 10 to the power minus 7 minus 0.3123 into 10 to the power minus 7. Okay, that will be equal to 1 by r. That will be equal to 1 by r. So taking 10 to the power minus 7 common, 1.563 minus 0.3123. Okay. So taking their value, write fast. Get it done, calculate it. Okay. 1.563 minus 0.3123. So it is 1.2507 into 10 to the power minus 7 is 1 by r. R is 1 by 1.2507 into 10 to the power minus 7. So 1 by 1.2507 is 0.799 into 10 to the power 7 meter. So R is nearly 8 into 10 to the power 6 meter. This is the answer. Okay, for this problem. So it will reach a height of 8 into 10 to the power 6 meter. Then it will come back to its. Come back towards earth. Okay, then it will come back towards earth. So that is how the problem must be done. I hope all of you have done it. Yes. So we'll move on to one more problem. Okay. Okay, we'll go to the next problem. Write the question in red ink, okay? Maybe this black ink is fading a little. Okay, write the first question. Suppose there existed a planet that went round the sun, twice as fast as the earth. Twice as fast as the earth. What would be its orbital size? What would be its orbital size as compared to I'll read it out. Suppose there existed a planet that went round the sun twice as fast as the earth. What would be its orbital size as compared to that of earth? Okay, so this I think you can do it. Okay, this we can probably do it. Is it visible or should I read out? Message something, no? So I'll read it out. Suppose there existed a planet that went round the sun twice as fast as the earth. What would be the orbital size as compared to that of the earth? So this is t square proportional to a cube. T square proportional to a cube, it is a cube it is. So what you do? See here, time period of the earth, there existed a planet now. So time period of the planet square should be proportional to orbital speed of the planet. So that we have to think of AP. Time period of the earth and this is orbital radius ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಹಾಗಾಗಿ radius of the planet cube by radius of the earth cube. So we have to find out the radius of the planet, I think. So time period, there existed a planet that went around the sun twice as fast as earth. So if the speed is 2 times, time period of the planet should be half, correct? Compared to that of the earth, time period should be half if the speed is 2 times. So that is t by 2 divided by t. That should be radius of the planet. Radius of the planet to be found. This is radius of the earth cube. So t cancels. This is 1 by 4 is equal to radius of the planet compared to that of radius of the earth. So that is cube root of this. cube root. Okay, that is cube root ಆಗುತ್ತೆ. So if I get this in now, that will be RP will be RE into 1 by cube root of 4. 1 by cube root of 4. The value, that is orbital radius of the earth around the sun, is around 1.5 into 10 to the power 11 meter by cube root of 4. This is what we have to calculate. That should be cube root of 4. Cube root of 4. Is that clear? Cube root of 4. So calculating this, this is the answer that we are going to get. Just calculate. Okay. This is see. You just calculate the answer now. Okay. So what is the answer for this? Just calculate the cube root using log. Okay, that is more important. So you can, I think this will come around, this will be more than 1. So this is 1.5 into 10 to the power 11. This value will be little more than 1. So cube root of 4, how do you calculate? That is 4 to the power 1 by 3. So 1 by 3 log to the base 10, 4. So just calculate and get the answer, okay? That is how it should be. Then take the anti-log, then calculate, okay? Then calculate the answer. Try to get the answer for this. Or else, see, radius of the earth with the sun, you can take it as 1 astronomical unit. That also can be done. Taking from here, see, 1 astronomical unit is RP by RE. That is, RP by RE is 1 by 4 of the cube. So that will be RP by 1 astronomical unit is equal to 1 by 4th of the cube. So radius is cube root of 4 into 1 astronomical unit. So whatever the answer that you are going to get is the answer. 1 by 4th, sorry. This is 1 by 4th of this. So 1 astronomical unit divided by cube root of 4. This is the answer. That will come around 0.63 astronomical units. See the orbital radius of the earth with respect to the sun is 1 astronomical unit if you take. This is what is the answer. Okay. you calculate this answer. Yeah, for both you require anyway taking cube root of 3, 1 by 3 log 4, whatever the answer you are going to get, take the anti-log of it, then substitute the answer here. That will give you the answer. Log ತಗೊಂಡ ಮೇಲೆ anti-log ತಗೊಂಡು value ನ ನಾವು find out ಮಾಡೋದು. Okay. So that is how you, otherwise this is the answer if you take it in terms of astronomical units. Thank you.